I just turned you on.
Okay.
Wow, that's amazing. Way on.
So my presentation is going to be on making a tank of this profile. So my background is mostly in cars. I'm mostly street rods. So very often I'd be building a Roadster or a coupe for somebody, a 30s era vehicle. And the best place to put the tank often is behind the seat. And usually there's a seat back angle, and it's efficient to make a tank that fits up tight against the sink so you don't lose so much of the trunk space. And the back side of the tank is usually vertical, so you get the maximum trunk space. And it needs space on the top for a filler cap and a sender for the fuel level, and a vent and all those miscellaneous accessories. So it generally will have a flat spot on top. So, and it's usually as wide as you can make it. I mean, in a street rod, you want to have a decent fuel capacity. 8 gallons doesn't cut it. You have to stop too frequently to top up your gas tank. So today's demonstration is going to be about how to do the layout and calculation and forming of a tank like this. So the place I start is by making a full-size accurate drawing of the profile I'm trying to create. So this is the layout, and in most cases you want to have a 90-degree corner. Well, I shouldn't even say that. The angles can be anything you want, anything at all. The dimensions can be anything you want. I just drew this out and measured it, and it came out to have just about a 90-degree corner here. It's about 1/8 of an inch off, but we won't let that slow us down. So if I'm making something this size and I get it within 1/8 of an inch, I feel like I've done a pretty good job. Now there are worlds in which that kind of error is, it'll kill people. Like if I'm making the airlock door for the space shuttle, 1/8 of an inch is out of tolerance and people will die. But for a gas tank behind the seat and a street rod, that's plenty good enough. If it's an inch off, that could be a problem. And there actually are quite a few intricacies in laying out something like this. And one of the biggest challenges is the fact that 2 of the angles are the same. They're 90, but 2 of the angles are not the same. And how many people have experience with laying out bends on sheet metal? About half of everybody. How do you do it? I mean, that's kind of a wide open answer. How long is a string? But, people do this in different ways. Many people use what's called the bend deduction. Many people use, a K factor. If you're working on a press brake, there's a K factor, which is used in work where thousandths of an inch is important. In my world, where 1/8 of an inch is good enough, I like to make it just as simple as I can. So I've developed a system that allows us to make a tank like this pretty fast and pretty easy. So where do we start? We're going to start on this corner. There's going to be a welded seam on this corner. Then we'll take one long piece of metal and make one bend here, and one bend here. And then the perimeter of the tank, the top, front, bottom, and back, is all done. Then the only other pieces needed are an end cap on the right side and an end cap on the left side. So that's the strategy. Everybody with me so far? So the trick is in knowing how and where to make your bends. So the how to make the bends is very easy to understand. As you can all see, I've welded a square tube to a round tube, and this is my bending fixture. To make the bends, I just stick metal underneath it and lift it up with my arms and body. And who knows why I welded a square tube to a round tube?
So you could clamp it?
Yeah, it's pretty hard to clamp a round tube, and even if you do clamp it, when you put a side load on it, it rolls. So the square tube prevents it from rolling and provides an easy place to put clamps. So that's why we want a square tube attached to a round tube.
So the square tube is just tagging along.
Tagging along, yeah, keeping everything in alignment. And I have these in many different size radii. The smallest one is like a 5/8 of the tube. Oh. And it's pretty hard to clamp something that small, or it's better to have a bigger backer on it, even if your round forming surface is small. So that's why the round tube is welded to a square tube of some size. You want some bending resistance this way too. And a 1/2-inch square tube doesn't have much bending resistance this way. So this is our bending fixture. And the only tricky part is knowing how to do the layout such that when you're all done bending, it comes out the right size. That's the challenge. And why can't you just, Jerry, I'm looking for aluminum welding rod.
Right there. What size?
This size, 1/16.
Because the 332 is right under.
This is the one I want. So if you're making a square bend, you get one outcome. If you're making a bend, oh, this has got to be stainless or something. It's not cutting the way I.
How it didn't cut.
It looks like
Yeah.
stainless.
Down in here. Okay, yes. It was stainless.
I'll let you put this back where it goes. I know you don't want to mix them up.
316L.
Oh, this rod is all wrong. It's got a 0 on the end of it. That means a scrap. So let's cut 3 pieces of welding rod to the same length, and you'll see where I'm going with this in just a minute. So 3 rods the same length. Let's put a center line for the bend on each of them. And we're going to make a sharp bend on the first one. We're going to make a small radius bend on the second one.
The center line is the center of the bend, or
Center of the bend.
tangent point?
Center of the bend.
Center, okay.
And a big radius bend on the last one. And look at how the end points on these change. Can you see where I'm going with this? Mm-hmm. So all 3 ends end in a different position this way. So that's why the radius of the bend makes a difference when you do the calculation and layout for each bend. How many people are following me so far? Everybody. Okay, great. So there are mathematical ways to do this kind of layout. It gets a little more challenging when the angles aren't 90 degrees, but it's still possible. Ron Covell is an individual who sucks with math. So, maybe I shouldn't have said that. Who is poor at mathematics, at arithmetic. So Ron Covell will always find another way if he can. And in this case, I can. So what's the technique? Well, the technique is starting with a scrap piece of metal and making a layout that shows all of the bends. So from the first bend, from the first corner to the first bend, the dimension will be 4 inches. So this is where the end is, and the first bend will be 4 inches away from that. So I've made a line there. Then the next run will be 17 inches. So the next line is 17 inches from the first. The next run is 10 inches. So there's a line 10 inches from there. And the remainder is 16 inches. So that's what this is cut to. So we're going to bend this, and it's going to be too big. But we can measure how much it has grown, and then using those dimensions, we'll subtract them when we do the layout for the final part. That's not too hard to understand, is it? That's the kind of thing my mind can follow. So that's the technique we'll use. And to begin with, when we get all done, I want the welded corner to have the same radius as everything else. So we're going to use the beading machine with special dies to curl the edges that will create the welded corner. So that's the first step. Any questions before we do the curling of the edges?
Ron, the inside line is the inside of the tooth, right?
No, not quite. Go ahead and ask your question, but I think...
Why aren't you using the center of the tooth rather than the inside of the tooth?
That's a fair question. Can you ask that question after I've used this machine and put the board back up? Who asked the question?
Right.
Yeah, just ask that question after the next deal I'm doing, and I'll be happy to answer it. My answer will make a lot more sense if I can draw pictures. If I wave my hands in the air, nobody knows what I'm talking about. So we're just curling that edge over to 45 degrees, and that's what the round over dies do.
That is where it is now. Yeah.
So I'm just setting the tension between the dies. I want light tension, not necessarily heavy pressure. That should be good.
Oops, wrong way. That's the way you want to go.
Yeah, thank you, Jere.
Speed.
I like the speed. So one pass is all it takes. So it's a 45-degree curl. I'm using 1/2-inch radius dies, so these are making a 1/2-inch radius curl. The same radius as a piece of 1-inch tubing would have. My bending fixture is a different radius, but I'm not going to let that slow me down. It is what it is. So we've done the ends. Now we're going to make the bends. And before I make the bends, there was a question I had to answer. And I forgot what the question was. What was the question I was answering? Oh, yeah. So the question is the layout for the bend done from the center? No, it's not. Could it be from the center? You bet it could. And if you're using a press brake, it would be. But I'm not using no press brakes. No siree. I'm using inexpensive shop-built equipment. So my layout is just done in a different way. If you saw me do my setup here, what I did was I used a combination square to set up my fixture so it's in line with the edge of the table. So the front edge of the tube is perfectly in line with the edge of the table on both the front and back. So looking at what that looks like, seeing what that looks like, my setup is done like this. And my reference line for all of my bends is this point right here, the crisp square edge of my table. Now that's going to be somewhat close to the center of the bend, but it's not the center of the bend. And think through this a couple of steps farther. One of the bends is over 90 and one of the bends is under 90. So they couldn't both be on center doing it this way. You with me? And even doing it 90, it doesn't come out to be exactly center. Close, but no cigar. So does that make sense? Yes, no, maybe?
I don't think that does.
Well, I won't let that slow me down. So let's bend our test piece.
So center is just not always center.
Let's not even talk about center. Ron Covell doesn't do his layout from the center. He does it a different way. He does it from the edge of the table. It's easy to find and measure and all of that stuff. So with my setup, I've got one clamp that never moves. So this tube can't shift on this end because I'll never release the clamp. On this end, there's a stop block that limits how far back this tube can move, so I can release it and reclamp it, and it will repeat with great accuracy. So we're going to line it up for bend number 1, clamp our tube down.
And your line is on the edge of the table.
Thank you for saying that, Jere. Yes, it is. So my bend line is on the edge of the table. And the first bend is not 90 degrees. What is it? It's a whatchamacallit angle. So this is Ron's little device for measuring angles. I don't like numbers, so I do it graphically.
Yeah. And rappingly.
Rappingly. No numbers, no math, no arithmetic. What I've taken to saying lately is that I have a mind that turns numbers into jello. So that's why I don't do anything that I avoid mathematical solutions to problems. I'm not saying that's a bad way to solve a problem, but it doesn't come naturally to me. So I've set my bevel protractor. Sliding T-bevel. I've set it to the angle I want the bend to be. And metal always springs back some, so we'll go a little past what we want, then counter gravity, and we need to go a little more. Jere, I will need a tape measure in about 3 minutes. Actually, if you're up, a tape measure and a a 3-foot scale. Could somebody grab one of those 3-foot yardsticks off the table and hand it to me? Thank you. So bend number 1 is a done deal. Perfect, thanks. We'll get set up for bend number 2. And one thing I forgot to mention that actually is quite important. I marked this end says in, I-N, and it has an arrow. So my sequence of bends start from this end, and then I make the bend sequentially, always moving in the same direction. If I'd started from this side, it wouldn't come out correctly. So we have bend number 1 accomplished. Let's get set up for bend number 2 in the same way. So I'm guessing you all would agree that this isn't hard. You know, the layout is easy to understand, it's easy to make the bends, no numbers are involved, so everything is coming along swimmingly. And I'll just eyeball 90 on this. Get set up for bend number 3. So this is the bend we do over 90. And that looks pretty good. So as I was saying before, very often these ends will collide with each other. Actually, they're not colliding today. I don't know why. Let's just go with it though. Oh, I know why. It's because our leg lengths have all changed from what we wanted because of the bend, the growth at each bend. So we have 3 bends and 2 curled ends that are close to meeting. Piece of masking tape or a piece of any tape. Aren't there some other shorts here? So we will compare what we got with our layout and see how much each side has grown. So this will be hard for you to see when it's on the table, so let me get the board set up so you can get some idea of what I'm doing, and then I'll do the real measurement on the table. So it's close but no cigar. Can you see that it's almost an inch oversized here and about 3/4 of an inch oversized here? Can you all see that? But we need to know precisely how much oversized it is. So let's start with bend number 1. From the beginning edge to bend number 1, it has grown. Well, believe it or not, that one is right on the money. So with bend number 1, there is no correction. Let's look at bend number 2. Line this up on my pattern, and with bend number 2, just to get this show on the road a little more quickly, I'll make a mark on my paper where the edge is. So I'm lining up flush on the top and measuring how much below the line it is on the bottom. And it is...
Shouldn't it be the bend in the back now?
Don't confuse me. It's between 7/8 and 1 inch. Should I call it 15/16? I suppose I should. So between bend number 1 and bend number 2, it has grown, let's just say G, 15/16. Probably should call that 1 inch. I'm going to call it 1 inch because 16ths get confusing for parts like this. And if we get it within 1/8 of an inch, by definition, I'm saying that's good enough. So let's see how much it has grown between bend number 2 and bend number 3. and it has grown. Half inch. G is for grow. And then between bend number 3 and the end, it has grown a half inch. Huh, it's unusual that they're similar like that. So the dimensions we started with were between the edge of the part and the bend line, number 1, was 4 inches. There's no change with that. So bend number 1 is 4 inches from the edge. Going between bend number 1 and bend number 2, it grew an inch. So the goal is 17. We subtract an inch. It'll be 16 inches to bend line number 2. Everybody following me? And between bend 2 and 3, it grew a half inch. The goal is 10 inches, so we want 9.5 inches. And between bend number 3 and bend number 4, it grew a half inch. The goal is 16 inches, so we want 15 1/2. Am I making sense so far? So this is the simplest way I know how to do it, and it served me quite well for many years. And if somebody knows a better way, I want to know what it is. Honestly, I do. But you know, so here's the blank we're going to make our tank from. Today's tank will only be 12 inches wide, but it could be any width you want. And this is the side we're going to trim the waste off of. I've already marked which side goes in. So our first bend is 4 inches from the end. So I'll use a yardstick, a 4-foot scale to lay out a bend line 4 inches from the end. Oh, and we should talk about how you calculate the volume of tanks. Maybe this isn't the time. Let me, get through the part where I have to think about what I'm doing, and then we'll talk about the volume. Yeah, this is based on an inexpensive beading machine, but Jere's fixed all the problems with those, so I forget that he's done all that. So these dies, if you haven't looked at them closely, have like a flange or a guide built into the bottom die. So as long as I'm putting just a teensy bit of pressure on the metal this way as I go, it'll always stay tight against that guide. If I forget what I'm doing or accidentally put a little pressure this way on this edge, the edge close to me, it'll crawl away from that guide. And even if it does, you can come back and make another pass. But the idea is you need just gentle pressure to keep it tight against the guide. And if it stays tight, you'll get a very consistent curl.
Dives.
It's 90 degrees.